Good morning, all of you. Myself, Sanskar Dhate from Ramdev Bhave University. Today, we are discussing about the topic classical double slit experiment with bullet and quantum double slit experiment with photons. Firstly, we will introduce our topic. The double slit experiment is a famous experiment that helps us to understand how tiny particles like wave electrons behave in different ways that are very different from we see in everyday life. It shows us that these tiny particles can act like both waves and particles. This experiment was first done by Thomas Young in 1801. He wanted to show that light behaves like wave, and his experiment helped to prove that idea. But later, when scientists started studying tiny particles in more details, they found that these particles can also act like waves, which changed everything we thought we knew about it. In this lecture, we compare how classical objects like bullets behave differently from quantum particles like photons. This comparison with helps us how strange and fascinating the world of tiny particles is. By the end of our discussion, I hope you will have a better understanding of how double slit experiment works, what wave duality means, and what these ideas are important in world of science. Now we discuss our topic in detail. The classical double slit experiment with bullet. Suppose we have a machine gun which fires a bullet and we have placed three slits in front of it. We target when it heads to beat. As the bullet travels, they can only go through one slit or the other. When we observe the detection screen, we see clearly two impact band forming. These impact align directly with the slits, demonstrating classical particle behavior. This outcome matches our everyday institution about how objects behave. They follow clear path without any interference. In this scenario, we can predict the result with certainty as classical mechanism governs the behavior of these bullets. Let me take an example here. Suppose we have a director graph given here which shows eight different points from which the bullets has been fired, and here the probabilities are given where the bullets get fired on it or not. Suppose if a bullet goes from 0 to 1, we have given the probability 1 by 2 here. So we will plot in the matrix here. This is one zeroth position as this is one position. So we have seen that 0 to 1, we have given 1 by 2 probability. So here we will plot 1 by 2 in the matrix. And the bullet does not go from 0 to 0. So we have written 0 here. Similarly, we will plot all the probabilities in the matrix where the bullet goes from itself. If it is goes 3 to 3, so we have plot 1 here, and this matrix is called adjacency matrix. The adjacency matrix is a way to represent the graph in the form of matrix. Now we will discuss about the term doubly stochastic matrix. And doubly stochastic matrix can be built by mixing different ways of rearranging rows and columns, and it is the combination of matrix multiplied by matrix itself. So it is the we can multiply two matrix B cross B here, so it gives doubly stochastic matrix. So we will multiply B itself to get the doubly stochastic matrix, and we have the different chances at we find bullet positions from here. Now we move towards our next topic, the quantum double slit experiment with photons. In this, we replace bullets with photons. In this quantum setup, we fire photons through the same double slit arrangement. If photons behaved like classical particles, we would expect to see two distant bands on the detection screen similar to the bullets. However, the results are different. Instead of two bands, we observed an interface pattern. This pattern consists of alternating high and low photon density, indicating that photons are behaving like waves. The interface pattern suggests that photons can interface with each other, much like water waves passing through the slits. This phenomenon challenges our classical understanding and highlights the wave-like nature of quantum entities. Let's take the example similar to the double slit experiment with bullets. Here we get the quantum double slit experiment with photons, and we have an example similar to the bullets here. We have different eight positions, and in this we get imaginary values instead of the real numbers or the fraction number values, because the photons have a high possibility that it will not hit the targeted point or it will interface with it. So here similarly we get 0 to 1, which have the possibility 1 by root 2. So we will plot 1 by root 2 here, and similarly we will plot the all entities here, and similar it goes from 3 to 3, so we will mark 1 here. And this is adjacency matrix, and this is doubly stochastic matrix. Similar we will find by P cross P, which will give us the doubly stochastic matrix here, and it is also called two click matrix. Now we move towards our topic, wave particle duality. Firstly, we will define what is wave particle duality. Wave particle duality is a fundamental concept in quantum mechanics which describes how quantum entities such as photons and electrons exhibit both wave-like and particle-like properties. In this, quantum quantities can behave as particles which have definite positions and can be counted, like bullets. And they also behave as wave which can interface and exhibit pattern like wave water waves. So here we use the double slit experiment, which highlights wave particle duality. Quantum entities such as photons and electrons can behave as both particles and waves, depending how we observe them. This duality reveals the quantum mechanics, which is proved that it is uncertain and probabilistic, unlike classical mechanics, which provides deterministic outcomes. Quantum mechanics embraces this uncertainty. These implements of this duality are profound as they suggest our understanding of reality is not same as we expected, and it is not also straightforward. Classical mechanisms cannot find fully explain this duality, and quantum physics accept this uncertainty. Now we will like to conclude our topic, and we will recap what we have seen in this PPT. Previous slides, that what is double slit experiment and the classical double slit experiment with bullets. Here we take the example of classical double slit experiment with bullets. Here we describe what is quantum double slit experiment with photons, and we have taken an example of it. And we also define what is wave particle duality. So the double slit experiment reveals the strange nature of quantum world. By comparing classical behavior with quantum behavior, we gain insights to the fundamental principles of quantum mechanics. This experiment highlights not only wave particle duality, but also the observer effect, where the act of measurement influences the outcome. Ultimately, it shows that the quantum is filled with probabilistic and uncertainties and challenging our classical institutions. So, I hope this lecture has sparked your interest in fascinating world of quantum mechanics. So, thank you from my side.